Okay, today we're ready for 13.1, right triangle trigonometry, day 3. So what we work on today is if given one trigonometry value, can you find the other 5? So we tell you the sine is whatever value, and then you go off and find the other 5 of them. So here's the problem we're given. In a right triangle, the cosine of theta is 7/10. Now find the other 5 trig functions. And ultimately, what we need then is a bunch of blank space, and it's going to help if we draw our own diagram. Now what I'm going to start with here is drawing a right triangle, and I'm not really too concerned with how big the sides and angles are. It doesn't really matter which side is bigger or smaller, which angle is bigger or smaller. This isn't meant to be very accurate, just a frame of reference for us to look at the various measurements involved. So I'm also going to place theta somewhere right now, and all that matters is that I don't put it with the right angle. So I'm going to put my theta up there. You could have put it down there. Would not have made a difference. Now I'm going to use the fact that if I know the cosine of theta equals 7/10, well, I'm thinking from SOHCAHTOA CAH that cosine is adjacent over hypotenuse. And this allows me to draw a direct connection between the measurements of the cosine value I have and how they might tell me about the size of the triangle. So I'm now going to label the side adjacent to theta is 7. That's not this over here connected to theta, because we know that's across from the right angle. That's going to be the hypotenuse. So of the 2 legs, we're looking at the one adjacent to theta right here. Put a 7 there. And then I know that 10 is the hypotenuse, and we just talked about the hypotenuse is across from the right angle. There's the 10. Now, once you do that, it's basically just like the work we did last week now. Or sorry, not last week, yesterday. Where now we have a diagram and we can go ahead and do the rest of the work. So the majority of the new stuff for today is just this idea that if you're given a trig value, you can use that one trig value to draw your own diagram. Now from there I have a missing side, so I know I'm going to use Pythagorean theorem, a squared plus b squared equals c squared. I know c needs to be the hypotenuse, it's 10. I know a and b are interchangeable. So I'm going to do a is 7 squared plus b is missing equals c is 10 squared. 7 squared is 49 plus b squared equals 10 squared is 100. Then I can subtract 49 on each side for b squared equals 51. Then a square root on both sides for b equals radical 51, the square root of 51. Remember, we throw away the negative radical, and that cannot be simplified. It's not a perfect square, and so we stop right there. b is radical 51. So now I'm ready with all 3 sides known to go ahead down here and fill in my values. So for sine, I'm thinking opposite over hypotenuse. So I come back up here, I find theta, I go opposite radical 51 over hypotenuse 10. That's radical 51 over 10. And that's great. The radical's in the top, so it's good. Now before I move on to the other ones, I'm right away going to do the cosecant, which is the reciprocal. So that's 10 over radical 51. Now the problem there is there's a radical in the denominator. So I mentioned this yesterday in the day 2 notes, that if a radical shows up in the denominator, you need to rationalize the denominator. You can do that by multiplying top and bottom by whatever the radical is that you want to get rid of. So on top, 10 times radical 51, this is the cosecant of theta, is 10 radical 51. You can just stick them together. While in the bottom, the radical 51 times radical 51, whatever's underneath the radical being multiplied by itself comes out, so it just goes over 51, no more radical. If 10 over 51 could be simplified, I would do that, but it does not get simplified, and so we actually stop right there. So far I've got the sine of theta is radical 51 over 10. I now have the cosecant of theta is 10 radical 51 over 51. When I move over for cosine, well, remember that's actually what we were given to start. So of course I could find it here as adjacent over hypotenuse 7/10. I can also use the fact that they told us the cosine is 7/10. Well, if the cosine is 7/10, then the secant is the reciprocal, and that's 10/7. No worries here about rationalizing the denominator. So we're good. So we've got our sine, our cosecant. Now we have our cosine and our secant. We're ready for the last two, tangent and cotangent. So come on back up here, think SOHCAHTOA. For tangent, I'm looking for opposite over adjacent. And that's opposite, radical 51, over adjacent, 7. So the tangent is radical 51 over 7. Again, radical in top means that works, so I'm all good on the tangent. Now the cotangent is the reciprocal. It's 7 over radical 51. Now with that radical in the denominator, I'm going to go ahead and rationalize that denominator. Multiply by a radical 51, top and bottom. 7 radical 51 sticks together. And whatever's under the radical when you multiply it by itself comes out, so over 51. And there's a rationalized denominator for my cotangent. So there's all 6 trig functions. Given the cosine, I was able to find the other 5. You can practice this right now on page 856 with problems 9 through 13 odd. That's just 9, 11, and 13. Thank you.